So today we're here with Joe Duffy, and we're going to talk about the CLR to PDC. What does that mean?
Well, so the CLR team has quite a few talks that are going to be at the PDC this year. So I've been spending the last 2 to 3 months making sure that we're able to showcase our technologies, make sure that the right people from the CLR team are at PDC to interact with customers and demo our new technologies, make sure we're giving the right talks. So that means basically breakout sessions, lunch sessions, panels, hands-on labs,
Cool.
Things like that.
First of all, who are you?
Oh, so I'm Joe Duffy.
And
Should I look at you?
we can have a conversation. It's just a conversation.
Scoble likes people to look at.
And what do you do here?
So I'm a program manager on the CLR team. Basically what I'm responsible for is like threading in the framework. So I work a lot on the concurrency problem. I do a lot with WinFX, so I drive like WinFX API reviews and things like that. So
Very cool.
a lot of random
So
buckets of
you
stuff.
know where the bodies are buried in Windows Vista, right?
That's right.
So there's a lot coming. There's a lot of changes in CLR 2.0.
Yep, there is.
Talk about that. One of the things you just mentioned is concurrency.
Mhm.
Big problem.
Yep.
Hard problem.
Yes, very hard.
What are you guys doing in the CLR to alleviate that? It's hard to write threaded code, so you're saying you're going to try to make it easier to write threaded code for managed developers?
So one of our biggest goals moving forward is making it easier.
Okay.
It is hard today, so what we're doing at the PDC is trying to teach developers how to work with today's technologies, some best practices to avoid common pitfalls, what APIs we ship that help you take advantage of the concurrency of your platform, various architectures that are going to be coming out in the years to come, and things of that nature. So we're really focusing on what you can do with today's technology. Now, there's a lot of improvements we've made in 2.0 that help you do that easier, make it, let you take advantage of the platform better.
Cool. Well, let's talk about some of those.
Sure.
Who's the gentleman standing at the door?
Hi. Hello.
How are you doing?
Good. I'm Jan Gray. I work in the office of the CTO on programming models for concurrency.
All right.
And I'm an ex-CLR performance guy.
Did the IQ quotient in the
Yeah,
room
just
just go
like
up
the
to like 30
range.
points?
So Joe and I are giving a two-part talk on programming with concurrency.
Excellent.
What is and it's programming for multi-processor, multi-core, right?
Yeah, so concurrency, parallelism, multi-threading, these are all confusing terms, and Jan's probably a good person to explain them. He deeply understands the various semantics of the terms.
Oh,
so.
great. Well, concurrency is the
You
ability
can go up on the whiteboard if you want.
for your logically for your code to be doing several things at the same time. The way it's usually manifest is in code that uses multiple threads. Even on a one processor machine, you may be doing one thing, and there may be a task switch, even within your own app, to another thread to go and do something, whether it's an event-driven thing or whether it's because you're running actually multiple threads of computation. In our two-part talk, the other thing is when we talk about parallelism, that's actually running 2 or more threads of work at the same time, thread-level parallelism. So we're giving these talks because we think that concurrency is something that's going to be more of an issue in more developers' thinking. There's 2 main reasons to have concurrency in your application. One is to add responsiveness, so you get a UI that doesn't block, even if it's going over the network or doing some slow operation or going to disk or whatever. And the second one is to add performance to your application for those applications that are kind of CPU bound. What we're seeing in, I'm going to draw a chart here kind of showing a trend over the last 30 years of where microprocessors have been. And there's really 2 curves. The famous Moore's Law curve of transistors per die has been doubling every 18 months to 2 years. Okay. And for the next 10 years, it looks like it will double every 2.5 to 3 years, the number of transistors per die. Along with that, we've been riding a curve of the CPU clock frequency has also been doubling at about the same rate. And that's been great. So we got this other curve here of the CPU clock frequency was getting faster and faster. And that was great because when you ship an app last year, next year's machine runs it that much faster. But that happy free lunch is over, as Herb Sutter put it. So we're the clock frequency that CPUs are improving at is going to basically stop or grow at a very slow rate going forward. So we're in a future now where you have processors that don't get any faster, but you get more and more cores per die, because you can still use these extra transistors to achieve more cores. So this year we're seeing the PC processor vendors shipping 2 processors on a die. And we see that that trend will just continue about every 2 years, doubling the number of processors on a die. Indeed, in the mainstream lifetime of a Windows Vista PC, we're going to start seeing 4-threaded and 8-threaded machines.
Now, these are on desktop machines, right? Probably laptops lag behind that, right?
You may also see laptops where they have several cores, but when they're in a mobile environment, you're running on one core and the other's powered down, something like that. And then at the other extreme, servers, you start getting, a server with 2 sockets can start looking as a 4 or 8 core server, even in the fairly near future. So to take advantage of these machines and to have our software keep growing in its capability to handle more data or go faster, we're going to need to start leveraging concurrency in our programming models. So the first talk we're giving, Programming with Concurrency 1, is more of a 300-level introduction to programming with concurrency. So you've never written a multi-threaded app. What are the essential things you need to do? How do you use threads, shared memory, and locks? What pitfalls, as Joe mentioned, should you avoid?
Now, when you say 300 level, there's 100, 200, 300, and 400.
Right.
And PDC is mostly for smart people who
So this talk
explain,
will not
because
go
it's not
into
for me, right? I'm a 100 level guy. Right?
So this first talk will not go into really nitty-gritty interactions between the CLR and the OS. That's the second talk that Joe's going to be giving.
All right.
We're trying to structure it so that you can go to either talk and get benefit out of it. One isn't strictly a prerequisite for the other. If you're already doing a lot of multi-threaded programming with shared memory, Joe's talk you can go to without taking a look at mine. So that's the purpose of the 2 talks.
Excellent.
I was going to say and it spans languages, right? Or it's not going to be how do you do it in managed code.
So the talk will have both a managed and a native component, and going forward, we need to bring both platforms forward to take advantage of the threads. Certainly, we want to do the same thing we did for memory management with the CLR to get rid of a whole lot of bugs and headaches.
Sure.
Do the same thing for succeeding with concurrency.
So you'd have a
for the longer
concurrency
term.
manager, you'd have a thread manager, you'd have something that helps you under the covers take care of the nitty-gritty.
Yeah, what we want to do is have a programming model that still can expose and leverage the available concurrency in the app, but get rid of the error-prone race conditions and deadlocks that people can get into. Exactly.
Now, what part of this kind of programming can you do in managed code versus C++ on managed code?
In both cases, you can launch multiple threads and have them go and work on either separate computations or on shared data. And in both cases, you have the same kinds of
Now, I assume
pitfalls.
it's easier in the managed code world, or is it about the same?
I don't think it's particularly easier in managed code yet.
Okay.
We do have some improvements in with the CLR memory model that makes it a little bit easier to reason about lock-free programming, but most people don't have to reason about lock-free programming and thus won't really understand that.
That's really programming at the very edge when you're trying to write code that is careful to atomically update just individual words in memory and move the data structures forward.
Right.
We don't expect, nor do we recommend that most developers adopt those techniques because they're very, very error prone.
So in both cases, you're programming with locks and synchronization primitives that essentially map one-to-one to each other and are similarly difficult to reason about.
Now, if I'm just what we call a MORT programmer here, using VB, I'm probably just using single thread, right? I'm not.
Right.
I have to do something very explicit
So
to get into
going forward, certainly that we'll be able to do more concurrency in the libraries on your behalf. But we also anticipate programming models where you can still be in a kind of an isolated world where your code thinks it's the only code running on the machine, even though there are many threads going on around you. We did a similar thing in transaction server in the 90s, where on the server your application ran under a transaction. And so because you used the isolation that the database provided for the data, it meant that if you and I were both concurrently working on what turned out to be the same rows in the database, one of us would get retried. but you end up with a model where you were blissfully unaware of all that synchronization. You didn't have to be a PhD in computer science. You didn't have to understand P and V and all that kind of stuff. So we're hoping to provide similar models to all developers over the longer term.
Also, just to touch on the VB thing too as well. I mean, this is one of the primary problems that we're talking about is, if you're programming a UI application, you start a long-running operation on the GUI thread. That results in an application that isn't responsive. If you ever have had a hang, and our software is as much, does this as much as anybody else's, but you notice your application's unresponsive, you click it a couple of times, and then the window changes to, not responding in the title bar. I mean, that's usually a result of somebody writing single-threaded code when multi-threaded code would have been more appropriate.
Interesting.
Absolutely.
I have a few developers to talk to you about that.
Yes.
I have a couple apps that I rely on a lot, and I see that a lot.
Yep.
Is this something that an average programmer should try, or is it something that only
No.
an advanced programmer should try?
It's not about average or advanced. But my recommendation is this is something you want to apply if you need it. If you have a responsiveness issue or if you have a performance issue that is not amenable to simpler ways of addressing your performance issues. As an old CLR perf guy, my advice is first going to be look at your memory usage, look at the APIs you're calling. Are you calling them in appropriate ways? Are they too expensive for you? All of those things that you'll probably hear from Rico later.
Yeah.
Once you've exhausted all those and you need to go to concurrency for performance, then this is material that will be relevant to you.
Okay.
But there's no denying this curve in the long term. Imagine a world where processors just never got any faster. How
You
do
just
we
get more
keep
of them.
scaling up over time? Eventually, concurrency is going to be a factor in everybody's lives, and we hope by that point we have very easy-to-use models so that they're easy. Everyone can succeed with them.
Right.
And it's it would also be clear that it's a industry-wide solution. Windows will play a part.
Sure.
CLR, a bunch of things.
Libraries, applications, etc.
Precisely.
If I was a C# programmer and I wanted to try this,
Yeah.
right, what are the first 3 lessons that I need to, that I really need to think about or know about?
What I would do is I would direct such a person to 2 really excellent sources of material. The first is an article that was just published by Vance Morrison in MSDN called "What Every Developer Needs to Know About Multi-Threading or Shared Memory" or something like that. It came out a couple of months ago in MSDN. The second is a paper by Andrew Birrell, Birrell, who works at MSR. And if you Google for him, you'll find his paper
Or
on
MSN search
programming. I beg your pardon. Sorry, Steve.
The quarter in your little bucket.
The lightning will strike.
I use Google too.
If you went to MSN Search and looked up this fellow, you'd find his paper, Programming with C# Threads.
Yeah.
So those are the 2 things I would go look at.
Cool.
Great.
Anything else? Now, do you use concurrent programming on Channel 9 since you're the programmer on Channel 9?
Well, it's different because our code base is ASP.NET, so everything I'm doing is it's easy for me to write concurrent code in the sense that I'm not writing concurrent code. It's being taken care of me in the model of ASP.NET. It's a server model. This is a client issue. Very different.
Server model.
ASP.NET rocks. Server model rocks.
The nice thing about server parallelism is all these clients are bringing in units of work, and you can give each one to a thread. You can use some isolation model like transactions, and you're already there.
And it looks like I'm writing just in,
You're the only guy on the machine to your.
You better believe it. So from that perspective, it's a wonderful experience for programming. So actually writing, I don't like to spin up threads in ASP.NET. Just to answer your question, no.
Okay.
I mean, explicitly no. There's no need to do it. Right. So you're the MC. Where are we going next?
I'm the MC. So actually, I don't think we mentioned what we're doing today. We're actually
Thanks.
walking around and talking to
Channel 9
everybody.
randomness. Yeah, what are we doing? So,
Thank you, Jan.
Thank you.
PDC.
Want to come along with us, or you got
No,
work
I
to
got
do?
things to do. Thanks.
All right.
So
You got to ship. He has to ship.
So we're basically going to walk around and talk to all the CLR team members that are participating in PDC this year. The first of which is Joel Pobar, another program manager on the CLR team, who is right here.
Fellas,
Excellent.
how's it going?
Real well. How are you doing?
So Joel and I actually were sharing a talk on basically writing a compiler in 1 hour on stage. So he's actually done a similar style talk before. So take it away.
Wow.
Yeah, I mean, it should be a lot of fun.
Compiler in 1 hour.
In 1 hour, it can be done.
Okay.
I've done it before, and I've proven it. It can be done.
All right.
I actually did the talk back in Code Camp Oz, which is an MSDN run code camp in Australia.
All right.
I was down there for vacation,
Uh-huh.
and I decided, hey, I'll jump
Visiting
on a
your
plane.
family, clearly.
Of course,
Uh-huh.
of course. And I thought I'd jump on a plane. We went out to Wagga Wagga, which is in the middle of nowhere, basically. And we sat around at a university, and a friend of mine, Dominic Cooney, and I decided, all right, we'll spend an hour up the back in the corner of the room, seeing if we can, cook up a compiler in an hour. And we did it, and then we presented what we found, and kind of walked through.
Beautiful.
Now, other than impressing your friends, what do you learn? What do you learn by building a compiler in an hour?
Well, I think the main takeaway is that you really kind of deeply understand what the runtime is and how it actually executes code. And well, there's actually two facets. You first of all learn how a compiler works, and the scanning, the parsing, AST generation, and of course the funnest part, which is the code generation. And the code generation obviously targets the virtual machine, the CLR. And I think that code generation part, you then have to deeply understand what it is you're targeting in order to generate the correct code. And so you learn a lot about the CLR, you learn a lot about IL, you learn a lot about static type systems, you learn a lot about type system design, which is also a really fun, kind of interesting topic. And so that's the kind of the crux of the talk. We walk through.
Don't mean to interrupt you, but you're writing a compiler in C in 1 hour.
We're writing a compiler in C# in 1 hour. So C#, and we use BCL technologies like reflection emit, which is our code generation backend, and
Okay.
so it's all managed, all C#, and we end up emitting it's a very kind of subset language. I must say it's a subset language. We can do for loops, we can do assignment, statements like assignments, variable declaration, and we can read things from the console. So we'll end up walking through how we do all that kind of thing, and in the end we'll run a nice little demo, a console-based demo, which explores and shows off the compiler in all its glory. And I think the intent, we're going to basically give the code out at the end of the presentation, so you'll be able to take the code home and then extend the language if you like, so add while loops and do's and for eaches if you like, and that kind of thing. So
It sounds like a great learning tool, as you mentioned earlier, just
Absolutely.
to figure out how this actually works.
I mean,
The first time you did it, what was the hardest? What was the most challenging part of that?
I can't honestly say that there was anything really all that challenging about it. I think that it actually worked really well, and I'm hoping to get the same dynamic with Joe here. My friend, he's very much a kind of a functional language guy, and functional languages guys, they're a bit out there.
To Lua, if you've ever heard of that language,
Yeah.
probably not. But
Yeah, well, it's a cute little dynamic language. Anyway, the point is that we start throwing kind of pies in each other's faces, so to speak, where I give him crap about him being a functional language lover, and then he sends me crap my way. It's all dynamic languages, all that kind of stuff. So it'd be a lot of fun, and
Cool.
Since you two are real language experts, what makes a good language? What turns you on about a language?
well, I mean, personally, I
If
like.
somebody came in the door right now and said, "Here's an XYZ new language,"
Sure.
how would you judge it?
I like expressivity and just power, flexibility. So language that composes nicely. So I absolutely love in C# 2.0 the anonymous delegates feature. So it enables you to write the code that you want to write when you want to write it without having to jump through all the hoops of language syntax and semantics. And that's one of the reasons why a lot of people like dynamic languages. A lot of people say, all these type declarations everywhere just get in my way. I just want to write the code that is in my head. And that's kind of my ideal language, is a language that doesn't get in your way.
yeah, for me, I think the best language would be a language that stole the best features of the contrasting spectrum in languages out there, like the pure static to the pure dynamic and the functional. If a language goes around and steals the best parts from each like each of that contrast kind of thing, then I'd give it the thumbs up.
Well, you could have a functional dynamic language, right?
Yeah.
That'd be interesting.
Lisp is
Yeah.
functional and dynamic.
Yeah, there you go.
My favorite language.
See? Wow.
That's what he's going to make fun of me for?
No, now he's going to make fun of you for that.
Well, there's
That's
two of
not
you,
a
right?
dynamic language, man.
He hates parentheses, so
Oh,
he likes curly
wait a
braces.
minute. Yeah. I like the way you format that, too. Nice job. I do the same thing. New lines.
Yeah, there's definitely religious wars that can happen.
Absolutely.
With this kind of stuff, and you know that's one of the other kind of the thing that I want to get out of it. The typical whole like C# versus VB religious war. It's boring.
Totally.
Like, give me something new.
It makes no sense because in the end they're really very similar, right? So they're both running on the same virtual machine. You can do basically the same thing except for the more complex interop issues you can use with C#, blah blah blah.
Right.
But in anonymous methods, the problem with anonymous methods is they're hard to debug. They could be depending upon how big the blob is because you don't know what the
stack
method
trace
is.
kind of looks strange.
Yeah. But it's definitely coolness.
Yep.
Coolness.
Yeah. So that's the
Well, so your talk is on how to write a compiler in 1 hour.
in 1 hour.
And how long is the talk?
1 hour.
1 hour and 15 minutes, actually.
So it's really going to be how to write a compiler in less than an hour and get questions at the end.
Exactly. 15 minutes for Q&A.
Yeah.
Well, I'm going to check it out. That sounds
Great.
cool.
Excellent.
That should be fun.
See you
Nice
there.
to meet you.
So what source code do you have up here right now?
This
Proprietary.
is
Yeah.
actually this is actually the compiler I'm working on. I call it the good for nothing compiler, and that's the one
Nice.
we're going to be demoing at the PDC.
Well, it's a language where you have for loops.
It's
right
good for
on.
nothing.
Oh, okay.
You mean you're not done with your deck yet?
It's coming along.
Now-
Tweaking and tuning at the
Now
moment.
here's a question: how do you guys judge other people's source code? If you open his source code up right now, how would you what would you be looking for to say it's quality? he looked at the formatting right away.
I wouldn't look at anything. I would just read through it, and if it made sense in my own head, if I can understand what it was trying to do in 50 seconds or less, or 30 seconds or less, then it would be good code.
Absolutely.
I think a lot of people build too many abstractions, and then you sort of lose context, and you can't follow what the code's trying to do. So.
Yeah, I agree with that. Definitely agree.
Well, thanks for spending a few minutes.
No worries. See you guys there.
Absolutely.
See ya.
Where are we off to next, sir?
So next, we're going to talk to Brian Grunkemeyer, who is
right.
a dev on the BCL. I think you've actually talked to him in the past.
Yeah, we have.
He's been on the BCL team since the very beginning, so definitely one of the smartest devs on the team.
a rock star.
And he's actually moved on to work on the generics feature recently. So Brian is not here.
Who's that?
Brian.
Uh-oh.
Oh, we'll have to
going
come
on?
back.
That's not good.
Could it be that? I hope he hasn't spontaneously combusted, man.
I don't know. I saw him running around earlier.
There's green smoke in there.
Here's Lakshan, testing team. So if you want to just move on to the next.
Yeah, that'd be great.
Okay.
Yep.
You all set? Okay.
There's Brad Abrams.
So we'll talk to Brad Abrams and Krzysztof Cwalina now. They're doing a pre-con session. This is 6 full hours of goodness about API design.
On the weekend before the PDC starts, right? Or is it on Monday?
It's actually on Monday.
Okay.
Hey guys.
I'm gonna get over here. Okay. I gotta get with the window to my back. Yeah.
So you guys can just introduce yourselves and talk about.
Yeah. Who are you?
pre-con is.
I'm Krzysztof Cwalina, program manager on the CLR team,
Yep. And what do you do?
working on design guidelines, WinFX APIs, some BCL APIs.
And,
Brad
we know who
Abrams,
you are.
I coming back from just a few days ago. So, we're going to talk actually today about a little bit more on the pre-con that Krzysztof and I are given on design guidelines. Should be a lot of fun.
Excellent. Cool. So, shoot away, guys.
Well, let's talk
So
about
just give an overview of what the pre-con's about, what you hope attendees to walk away with, and just some of the goals.
You know, we've given this talk.
It's supposed to be a conversation, right?
We've given this. I thought I was telling you. Thank you. We've given this training class internally several times to people building the Avalon and Indigo and all this .NET framework. And what we've decided to do is to take that same kind of content and give it to the PC audience. But one thing we did, Krzysztof and I actually met with Don Box and Jeff Richter, people that we respect that have done a very good job in pre-cons in the past, and kind of got their ideas of, okay, how could we frame it better for a PDC audience? So you want to talk about what we are doing?
Yes, so we're going to have, I think, 4 blocks, and in each block we're going to talk about one truth of good API design. So I don't remember what are the truths that we selected.
Well, it's kind of a secret, right? You got to come to the, you got to pay money to come to the pre-con, so we're...
But you get a book out of it, right?
Well, the book will probably be there, so we'll see how that comes out. We are kind of working on that and doing page proofs.
Yeah,
and stuff,
some page proofs here. Introduction, chapter 1. Well,
I actually think that's wrong, isn't it, right there?
Yeah.
So what are some of the challenges of writing guidelines for thousands and thousands of developers to use? I mean, you're getting feedback from customers. Somebody comes up with what's a good idea, and then another developer goes, it's a terrible idea. I hate the way that's implemented. But how do you? It's an incredibly political, complex role.
I mean, it's basically consensus building is a lot of what it's about. Like, how do you? Because a lot of the guidelines have inherent value in sameness, in consistency, and so getting people to buy in there. And there's some strong personalities. I mean, you've interviewed many of them on Channel 9, so you know that we have to get. But luckily it's if you can form the kernel of a rational argument for one thing, it kind of is a slightly better design than another.
Sure.
Then it's pretty easy to sort of build on that.
Absolutely.
But since you guys are talking about APIs, when you first sit down at a new programming environment, how do you judge the APIs? How do you say, "Damn, this was designed well"?
Yeah.
Or this sucks.
Sure.
What makes something suck, or what makes something good to you?
Yeah. So we've been doing this for several years now, and we developed a process. So each team that designs APIs in WinFX, they come to this review and they prepare what we call review packet.
Yeah.
And the packet, one of the crucial parts of the packet is what it kind of samples illustrating how customers would use these APIs in simple scenarios. And that gives you, 90% information about how well this API will be, received.
But how do
by
you judge
customers.
it? When you sit down at a new environment, how do you judge whether it is a good API or a bad API?
Yeah, so it's simplicity. I think the most important part is simplicity. We look at the code samples. When we design APIs, we also write code samples, correct? And we look at the samples and we say, is it simple? Is it self-explanatory? Could I do that without understanding fully the technology, without reading documentation, without understanding all the types in the namespace? Can I at least implement the most simple scenarios? I think those are the best indicators.
Yeah, I try to find ties to things I already know. So I'm already a pretty good WinForms developer. I kind of know how to do that. And I'm going to learn in Avalon. Okay, are the concepts similar? The way I do data binding there, does it carry over there? If I can find ties to what I already know, then I think, okay, this is an easy thing. I can approach it.
Right. How does Whidbey measure up?
How does Whidbey? Well, Chris and I actually spent a bunch of time talking about that. Whidbey is better actually than .NET Framework 1.0. I mean, I think .NET Framework 1.0 we did a fabulous job compared .NET Framework 1.0 to almost any other framework. And Whidbey, I think we've gotten incrementally better on it because we've gotten a little more formalized. We had the design guidelines going into creating Whidbey, whereas we were building them the whole time with .NET Framework 1.0. So I think Whidbey's better, and then I'm really happy with the way Indigo and Avalon are coming together. They're really embracing those guidelines as well. So.
Do you, as an API designer, do you try to find a place where an API might take 50 lines of code to use and try to make it into one, or try to simplify?
Yeah, we try to make the simple thing simple. So we don't. If you're trying to build a low-level graphics renderer, we don't actually worry too much about making that simple. We worry about making that powerful and expressive so that ISVs can get done what they need to get done. But if you're reading lines of text out of a file, okay, that's something everybody's got to be able to do that. So one of the things we do is spend a lot of time sitting down with the people designing the API, saying, okay, who's the customer for this? what are they like? What are they going to be doing? And try to tease apart, are they this low-level developer we're targeting, or this kind of more high-level developer?
Yeah. Are they Scoble or are they Charles, right?
Yeah, there you go. Like, new personas.
Or are they low-level developers, or are they managed developers? Right?
Yeah,
that's not fair anymore. I take that back.
Yeah, I don't know about that. I mean,
you know what I mean.
But I think that even people that have an unmanaged background are coming in, and now you can do some really amazing stuff with Avalon Indigo and plug in at a low level.
True.
And it's also kind of, what is the scenario? Am I just prototyping and I want a, quick and dirty solution and I want to just get it done quickly?
Sure.
Or it's something like a critical, system component, and then I need to really understand what is happening at, every step in the program.
Absolutely.
When I was
That's a good point.
an editor at Visual Basic Programmers Journal, a lot of authors would compare things by just doing a Hello World app,
Yeah, yeah.
And that's not really fair to a framework or a language to do a real computer.
Yeah.
How much code do you have to write before you really have a good sense of how good the system is, and how it will work out for you?
Yeah, I think you have to know what the core value you're adding. So is the core value Hello World? Well, maybe, but probably not.
For me, maybe. Gotta start somewhere in your programming, right?
Yeah, exactly. So we were looking at a new workflow technology that you'll hear more about at the PDC, and we were thinking about, one of our big struggles as we started to review that API is, okay, what's the scenario? What are you trying to do? And at first, I think Krzysztof and I approached it, and we tried to do basically Hello World with it. And we said, this sucks for doing what is equivalent to Hello World. And they're like, well, okay, but that's not what we're trying to do. And so once we figured out what they were trying to do, what the core thing they wanted to accomplish was, then we were able to tell them, okay, now we understand, and now this is what you need to do to fix it to make that work.
What I was trying to get at is, how do you compare frameworks? As a developer, maybe I'm on a different framework today. How do I get, how much work do I have to do to figure out if .NET's going to be really appealing to me?
Yeah, so you're saying if you're like an MFC or a Java developer, and you're trying to see is .NET going to be more productive?
Yeah.
There's, I could send you to MSDN, lots of articles to read to see if kind of the core technology is there. But really, I think the best way to do is take a small project. Take something that's not mission critical, something you're not betting your business on, and go do the small project in .NET. Go do it in VB.NET, C#, and see how productive was that. What is your actual experience with it? And then that's a way you can judge it. I know one of the guys on our team, I think you're going to talk to Rico Mariani later today, but he actually was a developer on the EMFC libraries, and recently he rewrote an app. He had written an MFC, he rewrote it on .NET, and he had authored MFC, and he rewrote it on .NET on WinForms. He's a low-level CLR guy, so he hadn't really done WinForms before, and he found that it was so much more productive than MFC, even as the guy that had written parts of MFC. The number of lines of code he had to write, way less targeting WinForms than targeting MFC. So,
is there one part of the framework that you find customers find far more useful than any other?
Yeah.
Collections.
Yeah, he's saying that because he owns collection. I thought you were going to say message queue. If you notice, it bugs me. The design guidelines doc in the book, all the examples are message queue because Krzysztof owns the message queue. Like nobody else uses this thing but Krzysztof, but it's in every example, right?
Hey, message queue, event log, you will see those in design guidelines.
Yeah.
Fantastic. Is there one API that you guys are proud of? If you had another developer from another company or an MVP here that you would go, hey, check this out?
I don't know if it's an API, but I think the value type, reference type kind of unification that we've done there. So the fact, the API way to look at it is the fact that we have int and double and decimal, all these core types in the system that are just value types, and you can add those things to collections and turn them into objects as you need them kind of transparently. I think that's a major productivity win.
Okay. What's the one API that maybe is for advanced guys?
It's more for the more advanced users.
Yeah, if you had a rocket scientist, who would you...
Thread pool. I'll pick on Joe for a second.
Don't listen. You should use thread pool. Come to my talk at PDC, you'll understand.
Yeah, Joe will make it understandable.
Critical execution regions, maybe.
Yeah, and Whitby.
That's hard to get your head around. It's for hosting scenarios. Most people don't have to understand it, but it's about reliability. And Brian Grunkmeyer, who we'll talk to in a moment, is actually the expert, the resident expert on the team about that.
Runtime compiler services.
Yeah.
It's not even for humans.
Yeah.
It's for
I will tell you one of our tricks is if we can find a piece of the technology we think maybe isn't as mainstream, we try to. The technical term for it is we bury it. So look like 8 levels deep in the namespace hierarchy, and that's where we've put stuff that kind of needs to be there for the system to run, but maybe not. And like the system.runtime.compiler services, and that's actually where critical regions is as well. So there's some stuff down there that.
So that's where the advanced guy should go.
Go look. Yeah, I know everybody's gonna want. Oh, I want to go in there. That's where I want to be.
The more dots you have to type to qualify the type name,
yeah, exactly.
The more advanced the type.
Yes, definitely. Keep these things out of the mainstream. So.
Yeah. Any good obfuscation tricks for developers?
Obfuscation to obfuscate their APIs,
or to obfuscate their code, make their code hard to figure out.
Right. I was gonna say, do whatever you did in C. Just do that. And keep there's the Hungarian notation. Keep doing that. Put prefix every class name with C. Mm-hmm. Yeah, that'd be good.
Implement all interfaces privately, and expose public methods with completely different names.
Yeah, that's. These are actual things we've seen people do in everything. So one of the things we're doing for the pre-con is we're actually going to take actual review packets people at Microsoft have submitted for these are our APIs. Just rubber stamp these and talk about kind of what the issues are with those and how we ended up making those better. So I think some real world case studies.
Now, why do people do kind of stuff like that? Is it to have job security, or is it to impress their friends, or
or
is it just that their minds are really whacked out?
Yeah, I think that people build APIs for themselves, and that's who they're thinking about. Yeah. And the analogy I use there is, well, does the Office team build Word for themselves? Probably not. I mean, probably the Office developers, they know that they're building it for my mom or for an information worker. But lots of times when you're building APIs, you're a developer. I'm a developer. I like to use API. I like it when APIs take 50 arguments and I can do. Okay, that's okay, but for you. But turns out we have a broader customer set we're trying to target.
And the second issue is that lots of good things about APIs come from the similarity that Brad was talking about.
Yeah.
So when somebody else designs APIs and then they don't know the similarity guidelines that we use across the framework, well, they design pretty well APIs in isolation. Only when you look at the API in the bigger context of the framework, you may say, well, this is not how we would do it and how customers would expect it to be done.
So it's good the notion of the private API versus a public API.
Oh yeah.
I mean, API by implicitly one would assume is public, right? You want other developers to be able to use your API and understand it.
Yeah.
But private APIs also have their point. I mean, when you think about like SQL, the SQL engine and stuff that's going on there, that's not APIs that are exposed to developers, but they're probably damn good.
But it turns out lots of people in the SQL team have to use the same APIs. Yeah.
Right. So they're public, but it's qualified.
Yeah.
So they're still good.
There's one difference, and the difference is that you can change internal APIs. From release to release. So, you break people on your team, but you recompile the assemblies and everything works.
Sure.
Public APIs, the moment you ship it, you cannot change it. So now
forever.
Internal APIs are optimized for ease of change. There's no reason really to optimize public APIs for true change. More for an evolution. For evolution, yes, but not for change. You cannot change them. Why would you optimize for change?
Sure.
So those are some of the differences.
So if you have like a class that you think may change from version to version, make it abstract.
Yeah, may change. If you think it may change from version to version, why don't you not ship it until you're sure? But I do think one of the problems I do think people have is they design kind of for too much extensibility and too much abstraction, and kind of simplifying things down to the core essence is good. But yeah, the abstract, we're going to talk about, I know you're going with the interface to abstract class debate, and we're going to have that in the pre-con. It'll be good.
So go to the pre-con.
So it isn't part of the regular PDC package. You actually have to register separately.
Yeah, register
for it, right?
separately, right? It's the day before. You come in early anyway. You want to make sure you're there, so why don't you come in a day early and...
Totally. Fly into LA on Friday. We'll all be out.
Yeah, we'll be
have
there.
drinks.
Yeah, really.
Totally.
Now what level programmer really you want at this class? You don't want somebody like me who's just starting.
Well, we want people that are designing libraries for other people to consume. So one thing I found when I went out and talked to companies is big companies typically have a small group of people that are building reusable libraries that everybody else in the company goes and uses. And so those are the people we want. So if you're just working on an app, you're building a cool website, building a cool client app, you might find it interesting, but you're not the target audience.
Yeah. Well, cool. Well, thanks.
Thanks,
Some
guys.
time.
Yep.
It was fun.
Good luck. Bye-bye.
See ya.